Okay, so in this problem, we are looking at a kind of a weird shaped picture, and we're going to get the values of A, B, and C from the keyboard, and we have to calculate the area of the shape, the 3 interior angles, and the perimeter of the shape. So I'm assuming the 3 interior angles are in the triangle here. Okay, so we're practicing problem solving in this lesson. So we're going to go through like the input processing kind of output version of that problem solving model. So I think the input is pretty straightforward for us to see here, that we've got the 3 values A, B, and C. I'm just going to assume they're integers. Doesn't matter whether they're ints or floats for our problem, but and the output is just the 3 thing, or the I guess 6 things that it wants: the area, perimeter, and the 3 interior angles. But the processing is a little more complicated here than in some of our previous problems. So we're going to have to figure out exactly what is going on, or we're going to need to figure out formulas for the area, perimeter, and angles based on the values of A, B, and C. So we're going to have to do a little bit of algebra. So let's go over and take a look at this in a little more detail here. Okay, so here's my shape, and I don't know, maybe we'll start with like the area first. So I kind of see 3 different shapes here. So I got this the kind of the rectangle, the quarter of a circle, and the triangle, right? So if I'm looking for the area, then let's do the rectangle first. So the area of that rectangle is just going to be A times B, its length times width. The area of the circle, we know the area of a circle is pi r squared, but what is our radius here? So the radius looks like it's going to be well, it's this value here or this value here, which is half of the side length of this side, so it's half of A. So and it's a quarter of a circle, so it's pi r squared, but it's a quarter of that. So 1/4 pi, and my r is going to be A over 2 squared. Now the triangle is half the base times the height. Well, this is the base of the triangle, so that has a length of B, and this is the height of a triangle, so that has a height of C. So it is just half the base times the height. Okay, and so if I wanted the area of the whole shape, I'm going to have to add all of those up together. So that's pretty straightforward. Now the perimeter well, let's just start and go kind of around the shape here to see what's going on. So if I'm starting here, right, my first side for my perimeter is A, plus this side is B, plus this is A over 2, and then down this side is A over 2. Okay, now this quarter arc, so the circumference of a circle is 2 pi r, and it's only 1/4 of that. So it's 1/4 2 pi, and we already talked about the r value of that circle being A over 2. Okay. So now I've gotten this down there, over, down, and for the circle there. Now I got to do these slant values. So I'm going to call those S maybe, and there's 2 of them, right? So this way and then that way. because S is kind of an annoying shape to calculate. Well, it's not really annoying, but it's just the hypotenuse of, say, this triangle here. So if this is one side of the right angle triangle, and this side here is b over 2, so S would be, if you're looking at the Pythagorean theorem, or S squared is equal to c squared plus b over 2 squared. So S could just be the square root of b over 2 squared plus c squared. Okay, so I could just substitute that into my formula. Okay, so that's the formula for the perimeter. Now, if we're looking at the angles, okay, so two of these angles are equal because this is an isosceles triangle. So this angle here and that angle there are the same. Okay. So how are we going to calculate that? Well, I could use, I have the opposite side and I have the adjacent side, so it is just the inverse tan. So my angles, so my theta 1 is equal to theta 2, so those are the two equal angles, which would be the inverse tangent of opposite, which was C, divided by this length here, which is b over 2. Looks ugly, but the computer can handle that. All right, and then the third angle, which is this top one. We know the angles in a triangle all add up to 180, so if I just took 180 and subtracted those two values, I guess I don't even really need theta 2. Just use theta 1, and we'll print it twice. But the other angle, theta 2, is going to be 180 minus twice of theta 1. Okay, so I have all the formulas I think I need for this shape. Now I can just implement those in our code, and we'll check and see if it works. So remember, we're doing input, processing, output as our model of problem solving. Okay, so just think about what you need to get in from the keyboard, figure out the math or any logic that you would need to do to solve the problem, figure out what you need to print out, right? Write it down, plan yourself out ahead of time, and it'll make the coding go a lot smoother. So now that we're in our IDE, let's start doing all of this. I need to make a square root, so I'm going to import the math library. So we'll set it up so we've got our inputs, right? We've got our processing section, and we have our outputs for our problem solving. So I need the three values from the keyboard, A, so enter A, and we just need B and C as well. So I'll just make those changes. Okay, so there are our inputs. Now I need to do the processing. So let's do the area first. Right? So that was the rectangle, which is A times B, plus the circle, which is 1/4 times pi times A over 2 squared. Okay, so pi r squared and the quarter triangle, or sorry, the quarter circle. All right, and then we now have the rectangle, so half B times C. Okay, so there's our area. Now, for the perimeter, this was more complicated. So we had A plus B plus A plus a quarter times 2 pi r. Okay. So that takes us up to the end of the circle. Plus there was the two sides for the triangle. So we actually need to do that first, right? Because you have to calculate S before you can put it in the formula. So S would be the square root of B over 2 squared plus C squared. Okay. So there I've got my area. Now I've got my perimeter. And now I can do my angles. So my theta 1, so those two kind of corner angles for the isosceles triangle is we got to convert to degrees because we know we're doing trigonometry, and it's the arctan of C divided by B over 2. See if I got enough brackets there. There we go. So my number of brackets is correct. And then finally, theta 2 is going to be, let's say 180 minus 2 times theta 1. Okay. And then I can finally just print everything to the screen. So we'll print the area. And I think I said round to 2 decimal spots, so round area 2. Print the perimeter. So round perimeter. And then we'll print the angles. So we'll round theta 1. Got to print it again. And then theta 2. Okay, so there is my final code for that. It looked complicated at the start, but with a little bit of thinking ahead of time, right, we can produce a fairly straightforward solution. Right? We just now need to actually check to see whether that solution is correct. Well, if you've screwed up the math, you're going to get your check is going to be wrong too, but we can at least check to see whether our program is spitting out the correct numbers based on what our calculator would expect. Right? And to make sure, we should run the program to make sure that I didn't make any errors. Okay? So if I enter 3, 8, and 4, I get an area of 41.77, a perimeter of 27.67, and 2 45-degree angles and a 90-degree angle. Okay. So I could go ahead and I could check that manually with my calculator if I wanted to. I could talk to a friend to see whether they would agree with my math or not for those particular cases, and I could run it again for some different numbers if I really wanted to. Okay, but just remember, you want to do input, processing, output, and then somehow evaluate your solution to check to make sure that it is working correctly.